Hello, and welcome to this sixth video in our ongoing series of videos about the use of formic acid in animal production. Today's topic is going to be a little bit different from the past. Most of what I've talked about has been acidification of feed, but today we're going to be talking about acidification of drinking water. As always, I'm your host, Joshua Genza. I'm the Technical Product Manager for Organic Acids and Amasil at BASF, and we're putting these videos together in collaboration with our North American distributor, Bulkchem. So we're going to take a little bit of a different tack with this video. We're going to start with some key questions that we're going to try to answer over the course of the video as to around the use of formic acid for the acidification of drinking water. First, of course, is why should I acidify my water? That's a fairly straightforward question. And then we're going to talk about what pH should you target. Now after that, we'll talk about how do you choose an acidifier, how do you determine the optimal dose, and then what equipment would you need in order to go ahead with something like this. So starting with the first question, why? The most obvious reason is to promote intake. Alkaline pH has been shown repeatedly to inhibit water intake in swine and poultry and other species. And it's also been shown to interfere with certain other water treatments that you might be doing on the farm, such as chlorination or use of certain antibiotics. Animals tend to prefer water with neutral to slightly acidic pH. And if you have high pH water, acidification of drinking water is highly recommended. Another value is, of course, hygiene. Water lines are very similar to the respiratory tract of animals. Water is very slow-moving, and is as warm as the barn through which it flows. There's lots of nooks and crannies within the lines themselves where bacteria can set up colonies and resistant films. Medications that you might be putting in your line, maybe you're using some sort of an ad pack in the summer to help with heat stress, and the nutrients in there can become a food source for these bacteria and lead to algae blooms or just persistent bacterial challenges that you're introducing to that bird or that pig every time they hit that water. So talking a little bit about the voluntary intake aspect of things, so a pH of less than 6.5 tends to promote voluntary water intake. General recommendations are good well water has a pH below 8.5 because 8.5 animals tend to drink dramatically less, but between 6.5 and 8.5 there is still less intake than you'll see at a slightly lower pH. And also this high pH tends to be indicative of other problems such as salinity, high concentrations of sulfates which can push animals off of water, high calcium concentrations which can buffer digestion, and chloride, total dissolved solids. There's lots of things that can be in that water that are responsible for driving that pH up, because pure water has a pH of around 7. Water chlorination is frequently done on farms in North America. But one of the things a lot of people need to be made aware of when it comes to using chlorine is that chlorine is also, the performance of chlorine is pH sensitive. So a pH below 7.5 enhances the effectiveness of water chlorination because you want the hypochlorous acid to be what you're adding to your water. At a higher pH, you're going to see that hypochlorous acid turn into the hypochlorate ion, which has no value as a bacterial control agent. Obviously, if you get down to too low of a pH, you have buildup of chlorine gas, but that's not really relevant for drinking water applications. The problem tends to be too high of a pH, not too low. And as it pertains to water hygiene, pHs below 4 promote water hygiene. This is because, as we said before, water tends to be a reservoir for different microorganisms on farm, and most of the microorganisms that we are concerned about are sensitive to environmental pH. For example, this is a table excerpted from the FDA's latest guidance for industry for FSMA, and they talk about the value of pH for limiting growth of pathogens, and they give some pH limits for some pathogens of traditional interest. There's also research in the literature. Giedick and Strauss and Haler have done some work where they looked at the minimum inhibitory concentrations of different types of microbes that you might find in drinking water and how the different acids compare. And as you can see, formic acid comes out as kind of the best in class as far as efficacy, and that's touched on really well in our first principles of feed acidification video, which I would recommend you look at if you haven't already. So coming up on our second question, what pH should I target? Well, it depends on what you want to do. There is not a one-size-fits-all, particularly when we get into the variations in pH on farm, but as far as there's not even one target pH. Maybe you're just interested in improving the effectiveness of your chlorination protocol. Well, then pH of 7.5 is what you need. If you're looking to increase voluntary water intakes, then 6.5 might be better. And if you're looking to promote water hygiene as part of an overall biosecurity program, then we recommend a pH between 3.5 and 4.5, because that seems to be the stress point for the vast majority of the bacteria of interest. So how do you choose an acidifier? Well, what you want is an acidifier that's able to achieve whatever target pH you've picked. And the harder the water that you have on your farm, the higher the starting pH, generally speaking, the more acid you need. We'll go in a little bit into why that's not a one-to-one, but and a good way to figure out whether or not the acid you're looking at can actually do what you want is to look at the pKa. So what we can see here in this table on the right is that formic acid has the lowest pKa, and that's the pH at which the acid will have given up half of its hydrogen ions. And that makes it kind of the point of diminishing returns. So if you want to get a pH of 4, using an acid with a pKa of 4.8, you're going to have to use a lot of acid in order to get it down to 4, because you've hit that point of diminishing returns, and every pH step lower, you're going to have to use increasingly more acid. Whereas with formic acid, it's got with a pKa of 3.75, we're still on the other side of that inflection point, which is why formic acid is particularly effective for those low acid targets. But if you're only looking to get your pH down to 6 or 7, then most of the organic acids will get you there. It just comes down to cost. There's of course the topic of organic versus inorganic acids, and I'm not going to do much more than just mention that now, but that is covered in depth in our first video. Obviously, you're running a business. Price is what matters. What's the price per 1,000 gallons of treated water once you've figured out how much will be needed of these different acids that you might be looking at to get where you want to go? And then worker safety. You want fewer touch points, the better. You want this to be something that the producers can do and kind of forget about it, because the more they have to touch it, the less likely it is to get done every time the way you want it done. So say you've decided that you wanted to acidify, you wanted to use Amasil A, for example. Well, then the next question is how do you determine the optimal dose? Unfortunately, pH is a poor indicator of what the actual dose needs to be. It's more of a general guideline. So if we look at this green line here, this is a water sample, a titration curve for a water sample we collected from a farm. As we see, the pH started between 7.5 and 8, and then we dropped down to a pH of 4. It takes somewhere around 0.08% Amasil A in the drinking water. So very low levels of acid in the drinking water. This next line is a line from another farm. As we can see, it started with a slightly lower pH, closer to 7.5. At 6.5, you needed about half as much acid if that was your pH target. But if you wanted to target 0.4%, if you wanted to target a pH of 4, you're roughly at the same amount, 0.08 to 0.09% Amasil A in that drinking water, despite the fact that they had different pHs at the start, and they had different amounts of acid needed to get them to the same pH at 6.5. Looking at this third line, it starts with an even higher pH than the first water sample, but needs an intermediate amount of acid at to achieve a pH of 6.5, and only half as much acid in order to achieve a pH of 4. This is because what's buffering these acids out in the water is different for each water sample, and that results in a very different shape of the curve potentially, and very different recommendations based on whatever you want your target to be. So what we recommend is, when you have determined, you need to do a little bit of experimentation. Your first is you can just pick a dose and don't worry about it. We don't recommend that, but that can be done. I know that some of the other products on the market, that's how they do. They have a dose that they know is not going to acidify the water too much. And if it doesn't get you quite there, then maybe you bump it up a little bit afterwards. You can send a water sample to a lab to generate a titration curve. This is a service we offer to anybody looking at Amasil A. We can usually get a curve back to you in a couple of weeks, and then we can make a recommendation from there. Or you can start with a low dose, see where that gets you, and then slowly bump up or down the amount of acid in the water until you achieve the pH that you're comfortable with. So you've picked your dose, you know what you want to include. What equipment do I need? Well, there's a couple of different ways you can do it. For most people, the quick and dirty way is to use their traditional 1:128 dosing medicator, something like a dosatron. The benefits to this is you're using equipment that you already have. It's passive dosing, so you don't need to run any wiring or anything like that. It's already there usually. Some of the downsides are that most of the ones that are installed in North America are not acid tolerant, so while it may be good for a while, eventually you'll probably have to replace it a little bit sooner than you would otherwise. And it requires making stock solutions. So that's what's represented by the orange bucket. You're going to have to mix formic acid with water because you're going to need a greater dilution than 1 to 128. So you're going to have to put some acid in a bucket, add some water, and then drop the line into that and then pull from that like you would with, say, a mix-up of a waterline medication. Longer term, what we recommend, it requires a little bit more of an investment, is the installation of a Stenner peristaltic pump. The downside is that you probably would need to buy one of these if you're not already acidifying your water, and it's active dosing, so you need electricity in the barn for this to work. Some of the benefits are that it is essentially infinitely low dosing. You don't need to mess with stock solutions. You can take the line from this thing and you can drop it into a 35 kg barrel and draw pure acid into the water at exactly the right dose, which minimizes worker handling, A, because you don't need to be mixing stock solutions, and B, because you can buy sufficiently large volumes that you can acidify 2-3 runs of a barn before having to change out the barrel, depending on the pH of your water. So in summary, water acidification can bring a host of benefits. It can improve water consumption, it can improve chlorination. I didn't have anything in here, but there is some indications that it might be able to improve solubility of certain feedline medications, particularly the ones that are hydrochloride based. And then you can improve, obviously, the hygiene of that water, making it one less source of potential bacteria being introduced into the animal. Everyone's water is different, so testing is definitely recommended, and we offer that support to anybody looking at our products. And the desired effect will definitely dictate the optimal product, dose, and equipment, and we'd be more than happy to help you make that decision. So at this point, I'd like to say thank you for your time. Please let us know if you have any questions about the use of any product in drinking water, but definitely Amasil in drinking water. Thank you.